Hello, so in today's lesson our learning target is I can solve absolute value inequalities. So essentially what we're going to do is we're going to combine what we know about solving inequalities with what we know about solving absolute value equations into a new technique that we'll do in this lesson. So let's start with a couple examples. So suppose we have absolute value of 2x minus 3 is greater than 7. So we're going to start out just like this was an equation. So our first step is we always want to isolate whatever's inside the absolute value. So in this case, it's already isolated for us. So the next step is we want to split it into the positive and negative case. So we have positive case here, or let's make it fancy and use different colors. We can do the positive case blue, and we can do negative case in red. So for the positive case, we're just going to take away the absolute value brackets, and we'll get 2x minus 3 is greater than 7. In the negative case, we take away the brackets. We're going to turn this into a negative 7. And there's one very big and important difference, which is that we need to switch this inequality sign so it's facing in the other direction. So now solving each of these, we add 3 to each side. We get 2x is greater than 10. Divide each side by 2. We get x is greater than 5. If we look at the other case, we're going to add 3 to each side. We get 2x is less than negative 4. We divide each side by 2. And we get x is less than negative 2. So now, in order to see how these stack up, let's graph them on a number line. So here we have a number line. 0, negative 2, 2, 3, 4, 5. So our blue inequality, we have x is greater than 5. We're going to leave an open circle. It's going to go that way. And in our less than case, we have x is less than negative 2. So that's going to go that way. So you notice our inequalities are going in opposite directions. So whenever we have a greater than case, so we have the absolute value is greater than something, we have what we call the or case. So we know that either x is less than negative 2 or x is greater than 5. So that would be our answer, because an answer in this range will satisfy the inequality, and an answer in this range will also satisfy the inequality. And this makes sense because if we think about it, if the absolute value of something is greater than some number, either this number has to be positive enough to overcome that 7. So for example, if we plug a 10 in there, we're going to get 2 times 10, which is 20 minus 3. So we'll get absolute value of 17 is greater than 7, which makes sense. Or the number has to be negative enough that once we hit it with the absolute value, it will be greater than 7. So an example of that could be like negative 5. If we plug in negative 5 here, we're going to get 2 times negative 5 minus 3, and that's going to be equal to absolute value of negative 13. Once we hit it with the absolute values, that's going to make it 13, which is greater than 7. So we're going to get these two areas on the other sides. And this area in the middle that doesn't work. So that covers our greater than case. Suppose instead we have, let's see, 1 for absolute value of x minus 7 plus 6 is less than or equal to 14. So This one is a little bit more complicated. So we're going to start out with what's always our first step, is we want to isolate the absolute value. So here we have a little bit of work to do. Our absolute value is here. So the first thing I would do is I would subtract 6 from each side. You get 1/4 times the absolute value of x minus 7 is less than or equal to 8. Then we have to get rid of this 1/4. So we're going to multiply each side by 4. These will cancel out, and we'll get absolute value of x minus 7 is less than or equal to 32. So now we're in business. Now we have the absolute value isolated. So now we are going to split it into the positive and the negative case. So this time I'll do the positive case in green. X minus 7 is less than or equal to 32. We're going to add 7 to each side. We get x is less than or equal to 39. In our negative case, we get x minus 7. We get a negative 32. Remember, we need to flip that sign so we get a greater than or equal to. We're going to add 7 to each side. I get x is greater than or equal to negative 25. So now we have a number line, 0 here, 39 over here, negative 25 over there. So let's graph each of these. We have x is less than 39, less than or equal to, so I have a solid dot. Going that way. And we have x is greater than or equal to negative 25, which is going to go that way. So you notice, in this case, our answers overlap. So in this case, where we have the absolute value of something less than or equal to something else, our answer is going to be this area in between. So they need to overlap in order to be a solution. So the way we'd write this is we'd combine these two, but instead of writing an or, because an or is not correct in this case, we would write negative 25 is less than or equal to x is less than or equal to 39. And that's because x is in the middle of negative 25 and 39. And this would be our answer. So remember, whenever we have an absolute value less than or equal to something, the solution has to be the area that's overlapped by both inequalities. Whereas if it's greater than, it's in either one of these areas. So we have the or case. So that concludes this really quick lesson on absolute value inequalities. And yeah, so that's it.